Okay, well now we're ready for lesson 6 in unit 1. We're going to move on into 2 dimensions. And we're going to see 2 different techniques. Today we're going to focus our attention on something called the tail to tip technique, or the graphical technique. And I just get you guys to turn to this part of your notes. And what I'm doing here at the beginning, you already have in your notes. I'm just going to illustrate it before we actually take on our first example. Here we have a collision between 2 objects. I say collision, you say momentum. So we're dealing with momentums here. One object is moving towards the east, the other one's going towards the north. They stick together and they go off to the sunset together. Romantic story. And we're going to try to figure out how we're going to analyze this. Now, the good news is it actually starts out the same way it would ordinarily, where we would start with the principle, which is conservation of momentum, assuming isolated system. And that leads to that the total momentum before is equal to the total momentum afterwards. Notice we have 2 separate objects before. So we have P1 plus P2 and 1 combined object afterwards, P1, 2. Now, for this new method, for 2D, we're going to stop right here. We're not going to put the MVs in here. We're going to leave it right here. And now we're going to see what this is actually trying to tell us. This one is saying that we are going to add these 2 vectors together. But we're going to do that using the method called tail to tip, or tip to tail, or however you guys actually had it described to you in Physics 20. And the P1, 2 on the other side will represent the resultant vector. That is the answer vector. So, how does that lead to a triangle? Well, I'm glad you asked. Let's start with P1. So P1 is going towards the east. So we'll label that there's P1. Now we need to add P2 to this, and it's going towards the north, but where do you add it to? And whatever you guys call it, it really doesn't matter to me, as long as you remember this, that it goes to the tip of the previous vector. So from the tip of P1, you'll add P2. So that's adding, and again, tail to tip, tip to tail, whatever you guys call it, just one right after the other. Put the second one to the tip of the first one. So just remember, to the tip. Finally, we have the resultant, and resultant is kind of like displacement. The resultant goes from start to finish. So you can see we started our addition here, we finished our addition over here, and the resultant will go from start to finish. So this represents the resultant, and therefore that would be your P1, 2. Notice it matches the direction in the diagram itself. And we also have to state put the angle in here, and we only have 2 possible locations for the angle. You can put it at the beginning or at the end of the unknown vector. Do you guys remember where we would put it? Answer, it's at the beginning. So at the beginning of the unknown vector, there's your angle theta. I'm just going to get rid of the start and the finish, and then there's our vector triangle. And then what we do is we analyze that triangle. And when you solve the triangle, you finish the question. Okay, so this is what we call the tail to tip method. And this is a great technique if the vectors are at 90 degrees to each other, because it leads to a right triangle, which is relatively straightforward to solve. All right, to illustrate that, here's our example. Now, if you want, I'm going to encourage you to read the question over. Can you build the triangle from this? What would the triangle actually look like? If you want, pause, give it a try. Or you can wait for me. It really doesn't matter which one you choose. So we have a car going to the west. I'm not going to worry so much about the quality. We're going to look around from the top here. So let's imagine we've got a car, and I'll just call that the car. and it's moving towards the west. Let's put some information on there. This is a 1,200 kilogram car moving at 14.2 meters per second. Then we have a truck going towards the north. So there's the truck. And it has a mass of 1,900 kilograms, moving to the north at 16 meters per second. Now they're going to stick together like birds of a feather. And then we have car, truck, kind of stuck together. And hopefully it makes sense that they're going to be moving in a northwest kind of a direction. There's our angle theta, there's our V, and that's what we're trying to find, V and theta. And when we've got that, we've solved our question. So I do recommend actually drawing a diagram. I think it really helps. Now, when we look at the question and we ask, well, what method do we use to solve this? Well, they're colliding. I say collision, you say momentum. So, stating the principle, we have conservation of momentum. So we have momentum total is equal to momentum total prime, still true. And therefore we have the momentum of the car plus the momentum of the truck, I'll go lowercase t for truck, is equal to the momentum of the car and truck together. Good. And now what this does for us is it actually leads us to be able to draw the diagram for this. So let's do that next. We start with the momentum of the car. It's moving to the west, so its momentum is to the west. So we have the momentum of the car going towards the west. And then we're going to add the momentum of the truck, which is going to the north. Remember, you add it to the tip. So to the tip of that, we have the momentum of the truck. And PCT is the resultant, going from start to finish. And there is the momentum of the car and the truck, or the resultant. And remember, you put the angle at the beginning of the unknown vector. Good. So remember, when you guys are drawing your diagrams, make sure you draw all three arrows, because it's a vector triangle, not just any triangle, and label all three sides and label the angle. Make sure it's fully labeled to get full marks. Now, what's interesting at this stage here is we no longer use the conservation momentum equation. All we focus on now is the triangle. So logically, we need to find those momentums first. So let's do that. We have the momentum of the car, which is mcvc, and the car's mass was 1,200 times 14.2. I'll just do the truck as well here, just to get all that tedious stuff out of the way. The truck's mass 1,900 times, I believe, 16. Good. All right, let's calculate those. So the first one is 17,040. And the other one's 30,400. All right, I'm a big writer. I think I'm going to need another page here. There you go, magic. Excellent. Let's put those numbers onto the triangle. So momentum of the car, 17,040. Truck, 30,400. Okay, and I am just going to transfer this over to the next page for myself. Copy that. Bring it down. And there we go. Okay, good. So now we actually have, now it's time to analyze the triangle. Okay, well, first of all, we want to do a little Pythag to figure out the hypotenuse here. So we know that in general, and I'm just going to choose, let's go with dark green. We have c squared is equal to a squared plus b squared, which leads to c, because we're looking for c being the square root of a squared plus b squared. And therefore, PCT, which is the hypotenuse, is the square root of, in this case, it doesn't matter what order we go in here, 17040 squared plus 3400 squared. All right, that comes about 34,850. But we're not looking for momentum, we're looking for velocity. So we now have P is equal to mv. So V becomes equal to P over m, specifically the momentum of the car and truck and the mass of the car and the truck. That's why it's nice to put subscripts there to make it really clear. So this becomes 34,850 divided by the total mass. And our masses are 1,900 and 1,200. Or 3,100. So I think this is just 2 sig digs. Sorry, I'm just going to give you a headache here. Oh, 3 sig digs. I'm wrong. That's why I check. That's 11.2 meters per second. So they're both moving together at 11.2 meters per second. This represents the magnitude of the velocity. So far, so good. I'm just going to take this picture one more time for our last stage. Just so I have it as a nice reference. Okay, now we need to figure out the angle theta. And if I just put up here at the top, SOHCAHTOA, relative to the angle here, can you see that P of the truck, that's going to be the opposite, further side, not touching the angle, and PC would be the adjacent, like this. So because we have O and A, that's going to represent tan. So we know that tan theta is equal to opposite over adjacent, which becomes 3,400 divided by 17,040. Now we simply take the inverse tan of that. I might as well show that the first time here. Do make sure you're in degree mode when you're doing this. So just check your mode, make sure it's degrees. And I get about 60.7 degrees. But then we have to use the blank of blank notation. If you remember this from Physics 20. And we need to know what goes in the blanks, north, east, south, west. All right, I'm just going to get rid of those. So I'm just going to impose on here. I'm not sure what color I want to choose. Doesn't really matter. Let's put on the northeast, southwest. So there's north, here's south, here's east, here's west. But you guys notice it's in the northwest quadrant. So to make things even easier for us, I'm going to get rid of the other two labels. And then we have just north and west. So that means that our answer is going to be in terms of north and west. But which one's which? And all you guys need to remember is that the second letter represents the axis that the angle touches, or the starting axis. And you can see with the angle right here that it's touching the west axis. Therefore, west is the second letter. That's where you're starting. From there, you're going towards the north. So it becomes 60.7 degrees north of west. Good? All right, so there's our direction, there's our magnitude, and we've completed our answer. So just a reminder here. When you have a collision question, remember you're going to deal with momentum. You still want to show the equation, but the equation here is only to lead to the triangle. The triangle is everything here. So we draw a fully labeled triangle, and in the end, we solve the triangle. And that's all there is to it. Good? All right, well, good luck on the homework. I'll see you in the next lesson.